Imagine you're floating in space. Ahead of you is the most terrifying object in the universe, a black hole. You've seen them in movies like Interstellar, a place where time bends, light disappears, and nothing, not even light itself, can escape. So, what would actually happen if you fell into one? Surprisingly, the first thing that happens is absolutely nothing. Let's clear up the biggest myth first. Black holes don't go around the universe sucking up everything like cosmic vacuum cleaners. If our sun magically became a black hole tomorrow without changing its mass, Earth wouldn't get pulled in. We'd keep orbiting almost exactly as we do now. The only difference, there'd be no sunlight. A black hole's gravity isn't magical, it's just gravity. The reason they're dangerous is because all of that mass is squeezed into an unbelievably tiny space. Get close enough, and gravity changes dramatically over just a few meters. That's where the real nightmare begins. If you've watched Interstellar, you've already seen one of the most accurate black holes ever put on screen. The filmmakers worked with Nobel Prize-winning physicist Kip Thorne, and the visual effects were based on Einstein's equations, not artistic guesses. That glowing ring isn't the black hole itself, it's an accretion disk, gas and dust orbiting so fast that friction heats it to millions of degrees. The black circle in the middle? That's not the black hole, it's its shadow. Light passing too close gets bent around the hole by gravity, creating a warped image of the glowing material behind it. Ironically, black holes are often surrounded by some of the brightest objects in the universe. As you drift closer, something incredible happens, not to you, to everyone else. Gravity doesn't just pull on space, it also stretches time. This is called gravitational time dilation, and we've actually measured it on Earth using incredibly precise atomic clocks. Near a black hole, the effect becomes extreme. To a distant observer, your movements slow down, your voice becomes deeper, your clock ticks slower and slower. Eventually, you appear almost frozen, but from your perspective, everything feels completely normal. Your heart beats the same, your watch ticks the same. The strangest part. Both perspectives are correct. Time itself is no longer universal. Eventually you reach something called the event horizon. Movies often show it like a glowing portal. Reality is much stranger. There's no wall, no flash, no alarm telling you you've crossed it. If the black hole is large enough, you might not notice the moment at all. Only after crossing does the horrifying truth become unavoidable. Every possible path through space now leads inward. Escaping isn't difficult, it's impossible. Not because you're trapped by a force, but because inside the event horizon, moving away from the center would require moving backward through time. According to Einstein's theory of relativity, nature simply doesn't allow that. Probably, but not immediately. For smaller black holes, the difference in gravity between your head and your feet becomes enormous. Before you even reach the event horizon, you'd be stretched into an impossibly thin strand of matter. Scientists call this spaghettification, but here's the twist. A supermassive black hole, the kind at the center of galaxies, is so enormous that the gravitational difference at its event horizon is much smaller. You could actually cross the event horizon completely intact, before tidal forces eventually become fatal deeper inside. Which means, crossing the point of no return might not be the moment you die. It might be the last moment you can still wonder what's coming next. And that's where science reaches its own event horizon. We know what happens outside a black hole. We know what happens at the event horizon. But beyond that, our best theories stop agreeing. Einstein's theory predicts that everything ends at a singularity, a point where space and time themselves break down. Quantum mechanics insists reality shouldn't work that way. Both theories are incredibly successful, yet together, they cannot describe what lies at the center of a black hole, which means the greatest mystery isn't whether you'd survive falling into one. It's that after more than a century of studying black holes, humanity still can't answer the simplest question: what actually happens next? Maybe one day we'll find out, but if someone ever does, they won't be coming back to tell us.